Hello, in this lecture we will find the area of the green triangle. In the drawing we have an equilateral triangle. Triangle ABC is an equilateral triangle and inside triangle ABC we have green triangle, and we want to find out the area of the green triangle. We know that angle FDE is a right angle, it equals to 90 degrees, and also the size of PD is 2 units and the size of DC is 4 units, and actually, as you already know, all the angles of an equilateral triangle equals to 60 degrees, and also all the sides of an equilateral triangle are equal to each other. That is to say, AB equals to AC, AB equals to AC equals to AC, to AC equals to BC. Okay, all the sides of an equilateral triangle are equal to each other. It means that AB equals to AC equals to BC in the equilateral triangle ABC. But we know that BD equals to 2 units and DC equals to 4 units. So, and BC equals to BD plus DC. So BC will be equal to 2 plus 4. So BC equals to 6 units, and also AB and AC are equal to 6 units. And we know that AF equals to BF. So if we define AF as X, then BF equals to EF. So BF also will be defined as X. So AB equals to X plus 2X. AB equals to 2X. But AB also equals to 6 units, because all the sides of this equilateral triangle equals to 6 units. So actually we got the equality that states that AB equals to 2x that equals to 6 units. Or we can say that 2x equals to 6 units, and if we divide this equality by 2, we will get that x equals to 3 units. That is to say, BF equals to 3 units, and also AF that equals to x equals to 3 units. Okay? In the next step, we will define FD as A, and DF will be defined as B. And in the next step, we will find the value of A according to the law of cosines. The law of cosines states that the law of cosines states that if we have it applies to any triangle in the world. So if we have triangle, this triangle, we know that this side is A, this side is B, this side is C, and this angle is theta. Then according to the law of cosines, C squared equals to A squared plus B squared plus 2 times AB times cosinus theta. Okay? According to the law of cosines, C squared equals to A squared plus B squared minus 2 times AB cosinus theta. Okay, so we actually can implement the law of cosines on triangle BFD, because in triangle BFD, this triangle, according to the law of cosines, A squared equals to BD squared plus BF squared minus 2 times BF times BD cosinus 60 degrees. So actually we implemented the law of cosines in triangle BFD, and according to the law of cosines, A squared equals to BD squared plus BF squared times 2 times BF times BD cosinus 60 degrees. This is according to the law of cosines. A squared equals to BD squared plus BF squared minus 2 times BF times BD cosinus 60 degrees. Okay? So actually A squared equals to BD squared. BD equals to 2, so BD squared is 4 plus BF squared. BF equals to 3, so BF squared is 3 squared. 3 squared is 9. Minus 2 times BF is 3 and BD is 2 cosinus 60 degrees. Cosinus 60 degrees equals to 1 over 2. So in total we got that A squared equals to 4 plus 9 minus 2 times 3 times 2 over 2. 2 over 2 is 1, so we can cancel 2, and what is left is A squared equals to 4 plus 9 minus 2 times 3 is 6. So 4 plus 9 is 13. 13 minus 6 is 7. Okay, so I write it down. A squared equals to 13 minus 6 Okay, a square equals to 13 minus 6, and 13 minus 6 is 7. A square equals to 7. Okay, we got that a square equals to 7 because 13 minus 6 is 7. Now we will take a root out of this equality, and we will get that a square, that a equals to the root of 7. Okay, a equals to the root of 7 units. So actually we can write here that a equals to the root of 7 units. Okay, in the next step we'll define angle BFD as theta, and we will define angle BDF as alpha, and we will define angle CDE as gamma, and we will define angle CED, this angle, as beta. Okay, and as you already know, the sum of the angles in any triangle equals to 180 degrees, and especially in triangle BFD, the sum of its angles equals to 180 degrees. So we'll create the first equation that states that the sum of the angles in triangle BFD equals to 180 degrees. Okay, so in triangle BFD, the sum of the angles equals to 180 degrees. That is to say, alpha 60 degrees plus alpha plus theta equals to 180 degrees. 60 degrees plus alpha plus theta equals to 180 degrees. Okay, that is in triangle BFD. The sum of its angles equals to 180 degrees. That is our first equation. And we will also create our second equation that states that the sum of the angles in this triangle DEC also equals to 180 degrees. Okay? So the sum of the angles in triangle DEC is 60 degrees plus gamma plus beta, and it equals to 180 degrees. So actually our second equation states that the sum of the angles in triangle DEC equals to 180 degrees. The sum of the angles in this triangle equals to 180 degrees. In the next step, we will add together equation number 1 to equation number 2. Okay? In that way, we will create equation number 3. So 60 degrees plus 60 degrees equals to 180 degrees. Here we have alpha plus theta plus alpha plus theta plus gamma plus beta. Gamma plus beta all equals to 180 degrees plus 180 degrees, it equals to 360 degrees. Okay, so in our second equation we have, in our third equation we have 120 degrees plus alpha plus theta plus gamma plus beta equals to 360 degrees. Here we will subtract 180 degrees from equation number 3 and we will get that alpha plus theta plus gamma plus beta equals to 240 degrees, because 360 degrees minus 120 degrees equals to 240 degrees. Okay, so that is our third equation that states that alpha plus theta plus gamma plus beta equals to 140 degrees. And we will create our fourth equation that states that the sum of the angles in the upper side of a line equals to 180 degrees. So if we focus on point D, the sum of the angles in the line segment inside BC of this equilateral triangle, the sum of the angles on the upper side of this straight line equals to 180 degrees. That is to say, alpha plus 90 degrees plus gamma equals to 180 degrees. Okay, so we can write that alpha plus 90 degrees plus gamma, that is to say, that is the sum of the angles in the upper side of the straight line BC, equals to 180 degrees. And it is also true to say that the sum of the angles of any straight line on the lower side equals also to 180 degrees. Okay, so we got in the question number 4 that the sum of the angles in the straight line BC equals to 100, in the upper side of straight line BC equals to 180 degrees. That is to say, alpha plus 90 degrees plus gamma equals to 180 degrees. Here we can subtract 90 degrees from the fourth equation and we will get that alpha plus gamma equals to 90 degrees. Okay, in the fourth equation we got that alpha plus gamma equals to 90 degrees. But we have alpha plus gamma also in the third equation, so we can actually substitute alpha plus gamma in the third equation by 90 degrees, because alpha plus gamma equals to 90 degrees. Okay, so we'll substitute alpha plus gamma in the third equation by 90 degrees. Okay. We'll get that theta plus beta plus 90 degrees equals to 240 degrees. Okay, so in the third equation we got that theta plus beta plus 90 degrees equals to 240 degrees. in the next step, we'll subtract 90 degrees from equation number 3, and we'll get that theta plus beta equals to 150 degrees. Okay? So we got that theta plus beta equals to 150 degrees, because 240 degrees minus 90 degrees equals to 150 degrees. So we have here in the first equation that states that theta plus beta equals to 150 degrees. We will subtract from the third equation theta, and we will get that beta equals to 150 degrees minus theta. Okay? Again, in our third equation, we have the equality that states that beta equals to 150 degrees minus theta. Okay? So, in the next step, we will use the law of sines in order to find out the value of sinus theta. What is the law of sines? Actually, if we have, it applies to any triangle in the world. If we have triangle that this side equals to A, this side of the triangles equals to B, and this side equals to C, and this angle is alpha, this angle is beta, and this angle is gamma. Then the following relationship exists between the sides of this triangle to its angles. According to the law of sines, A over sinus alpha equals to B over sinus beta equals to C over sinus gamma. So, according to the law of sines, A over sinus alpha equals to B over sinus beta equals to C over sinus gamma. Okay, again, in any triangle in the world, A over sinus alpha equals to B over sinus beta equals to C over sinus gamma. Okay, so actually we can implement the law of sines in triangle BFD. Okay, so in triangle BFD we can say that FD over sinus 60 degrees, FD over sinus 60 degrees equals to BD over sinus theta. Okay, so we actually implemented the law of sines in triangle BFD. So FD over sinus 60 degrees equals to BD over sinus theta. Okay, FD over sinus 60 degrees equals to BD over sinus theta. Okay, but we know that FD equals to A and A equals to the root of 7. So we'll substitute FD by root of 7, and sinus 60 degrees equals to root 3 over 2. And BD equals to 2 units, and sinus theta is sinus theta. So in total we got that root of 7 over root of 3 over 2 equals to 2 over sinus theta. Okay, here we can do the simple arithmetic. We'll get that 2 times the root of 7 over root of 3 equals 2 over sinus theta. Okay, we got that 2 times root of 7 over root of 3 equals to 2 over sinus theta. Here we can multiply this equality by sinus theta, and then we will multiply it by root 3, and then we will divide it by 2 times root of 7, and we will get that sinus theta equals 2 times root of 3 over 2 times root of 7. Okay, so we did here the simple arithmetic, and we got that sinus theta equals to 2 times root 3 over 2 times root 7. Here we have 2 in the numerator and we have 2 in the denominator, so 2 is cancelled. So we got actually that sinus theta equals to the root of 3 over root of 7. Okay, sinus theta equals to the root of 3 over root of 7. Okay, in the next step we will find the value of cosinus theta by using a trigonometric identity that states that sinus theta squared plus cosinus theta squared equals to 1. Actually, this is a trigonometric identity, and we can use it in order to find out the value of cosinus theta. Here we can subtract from this equality sinus theta square. We will get that cosinus theta squared equals to 1 minus sinus theta squared. Now we will take a root out of this equality and we will get that cosinus of theta equals to the root of 1 minus sinus theta squared. Okay, but we know that sinus theta equals to the root of 3 over root of 7. So sinus theta squared will be equal to 3 over 7. Okay? So the value of sinus theta squared equals to 3 over 7. So we can substitute sinus theta squared in this equality by 3 over 7 because sinus theta squared equals to 3 over 7. And we will get that cosinus theta equals to the root of 1 minus 3 over 7. Okay, we got that cosinus theta equals to 1 minus 3 over 7. 1 minus 3 over 7 equals to 4 over 7. So I write it down. Cosinus theta equals to the root of 4 over 7. Okay? Cosinus theta equals to the root of 4 over 7. The root of 4 is 2, so I write it down. So cosinus theta equals to 2 over root of 7. Okay, so we got that the value of cosinus theta equals to 2 over root of 7. While we have already found out that the value of sinus theta is actually equals to the root of 3 over root of 7. Okay, we have already found out that sinus theta equals to the root of 3 over root of 7 and cosinus theta equals to 2 over root of 7. Okay, so actually we found in the beginning of the lecture, we found that beta equals to 150 degrees minus theta. Okay, we found it in the beginning of the lecture that beta equals to 150 degrees minus theta. Okay, so if beta equals to 150 degrees minus theta, then sinus beta will be equal to sinus of 150 degrees minus theta. Okay, very simple. And we have the second trigonometric identity that states that the value of sinus alpha minus beta equals to sinus alpha cosinus beta minus sinus beta cosinus alpha. Okay, this is the second trigonometric identity that we will use in order to find the value of sinus 150 degrees minus theta when alpha equals to 150 degrees and beta equals to theta. Okay, so we will use this trigonometric identity in order to calculate the value of sinus 150 degrees minus theta. So it will equal to sinus alpha equals to 150 degrees and beta equals to theta. So we will get that sinus 150 degrees minus theta equals to sinus 150 degrees times cosinus theta. You should remember that we know the value of cosinus theta minus sinus theta times cosinus of 150 degrees. Okay, I will repeat again. We implemented the second trigonometric identity, the sinus alpha minus beta equals to sinus alpha cosinus beta minus sinus beta cosinus alpha. We implemented this identity in order to calculate the value of sinus 150 degrees minus theta when alpha equals to 150 degrees and beta equals to theta. We found out that it actually equals to sinus 150 degrees times cosinus theta minus sinus theta times cosinus 150 degrees. Actually, sinus 150 degrees equals to 1 over 2 and we have already found out that the value of cosinus theta is 2 over root of 7 all minus sinus theta. We know that sinus theta equals to the root of 3 over root of 7 times cosinus of 150 degrees. Cosinus of 150 degrees equals to minus the root of 3 over 2. Okay, so in total we got that 1 over 2 times 2 over root 7 minus root of 3 over root of 7 times minus root of 3 over 2. Okay, here 2 over 2 is 1, so 2 is cancelled, and root of 3 times root of 3 equals to 3, so we write it down. In total we got that all equals to 1 over root of 7 minus 1 over minus times minus is plus, so we'll get plus 1 over root of 7 3 over 2. So in total we got that sinus beta theta equals to sinus 150 degrees minus theta equals to 1 over root of 7 plus 1 over root of 7 times 3 over 2. So here we will take 1 over root of 7 as a common factor of this expression. We will take out 1 over root of 7 as a common factor of this expression, and we will get that actually sinus beta equals to 1 over root of 7 in brackets. We will have 1 plus 3 over 2. Okay, so in total we got that sinus beta equals to 1 over root of 7. 1 plus 3 over 2 is 2 and a half, or 5 over 2. So I write it down. So we got that sinus beta equals to 1 over root of 7 times 5 over 2. Okay, we found out that the value of sinus beta is actually 1 over root of 7 times 5 over 2. Okay, in the next step we will implement the law of sines in triangle DEC. In triangle DEC, this triangle according to the law of sines, dB over sinus 60 degrees equals to dC over sinus beta. So according to the law of sines, dB over sinus 60 degrees equals to dC over sinus beta. Again, D in triangle DEC, according to the law of sines. DE, I made a mistake here, is DE dE over sinus 60 degrees equals to dC over sinus beta. But you should remember that dE equals to B, okay, according to the law of sines. dE over sinus 60 degrees, dE over sinus 60 degrees equals to dC over sinus beta. Okay, dE over sinus 60 degrees equals to dC over sinus beta. But we know that dB equals to B, and sinus 60 degrees equals to the root of 3 over 2 all equals to DC equals to 4 units, and sinus beta, we have already found out the value of sinus beta. It equals to 5 over 2 times root 7. Okay, in total we got that b over root of 3 over 2 equals to 4 over 5 over 2 times root of 7. We'll do the simple arithmetic here, and we will get that 2b over root 3 equals to 4 times 2 times root of 7 over 5. In total, we got that 2b over root of 3 equals to 4 times 2 times root of 7 over 5. Here we have 2 in the numerator of this side of the equation, and we have 2 in the numerator of this side of the equation, so we can cancel 2, and then we'll multiply this equality by root of 3, and we will get the value of b. So actually the value of b will be equal to 4 times root of 3 times root of 7 over 5. Okay, we got that the value of b equals to 4 times root 3 times root 7 over 5. But we know that the area of the green triangle equals to the base of the triangle times the height of the triangle over 2. So the area of the green triangle will be equal to the base of the triangle, that is b, times the height of the triangle, that is a, over 2. Okay? The height must create 90 degrees with the base, and here this angle is 90 degrees, so the height creates 90 degrees with the base, that is b. So the area of the green triangle equals to b times a over 2. Okay, but we know that a equals to the root of 7 and b equals to 4 times root of 3 times root of 7 over 5, and we will divide all by 2 because it is a times b over 2. Okay, so the area of the green triangle equals to the root of 7 times 4 times root of 3 times root of 7 over 2 times 5. Here root of 7 times root of 7 is 7, and 4 over 2 is 2. So I will write it down. So the area of the triangle equals to 2 times 7 times root of 3 over 5 square units. So the area of the green triangle equals to 2 times 7 times root of 3 over 5. 2 times 7 is 14, so I write it down. So the area of the green triangle equals to 14 times root of 3 over 5 square units. Okay, so the area of the green triangle equals to 14 times root 3 over 5 square units, or in terms of numbers, the area of the green triangle equals to 4.85 square units. Okay, so the area of the green triangle equals to 4.85 square units. That is the answer to the question. Now I will summarize the lecture. Okay, so we actually wanted to find out the area of the green triangle. We have triangle ABC that is an equilateral triangle, and in any equilateral triangle all the angles equals to 60 degrees, and all the sides of an equilateral triangle are equal to each other. So we know that the side of the side BC of the equilateral triangle ABC equals to BD plus DC. BD is 2 units and DC is 4 units. So the size of BC is 2 plus 4. That is to say 6 units. So all the sides of this equilateral triangle ABC equals to 6 units. Okay? And we also know that AF equals to BF. Okay? And we know that AF equals to BF and BC equals to AC equals to AB equals to 6 units. If we define AF as X, then BF equals to AF, so BF also will be equal to X. So the size of AB is BF plus AF, that is to say X plus X, or the size of AB equals to 2X. And we know that the size of side AB equals to 6 units. So AB equals to 6 units, and AB equals also to X plus X. AB equals also to 2X. So actually we will get that AB equals to 6 units, and 2x that equals to AB equals also to 6 units, so 2x equals to 6 units. So we can divide this equality by 2, and we got that x equals to 3 units. So BF equals to 3 units and AF also equals to 3 units. Okay? Then we defined FD as A, FD equals to A, and DE equals to B. Okay, DE equals to B, and then we implemented the law of cosines in order to find out the value of FD. According to the law of cosines, in any triangle, if this side equals to A, this side equals to B, and this side equals to C, and this angle is theta, then the following relationship exists between the sides of this triangle. That is to say, C squared equals to A squared plus B squared minus 2 times AB cosinus theta. Okay, it is true for any triangle. Okay, so we can implement the law of cosines in triangle FBD, this triangle. And we can say that FD square or A square, because FD equals to A, so we can say FD square or A square equals to BD square plus BF square minus 2 times BD times BF cosinus 60 degrees. According to the law of cosines, A square equals to BD square plus BF square minus 2 times BF times BD times cosinus 60 degrees. Okay, so A square equals to 2 square plus 3 square minus 2 times 3 times 2 times cosinus 60 degrees is 1 over 2. So we got that A square equals to 7, so we took out a root out of this equality, and we got that the value of A is the root of 7 units. Okay, A equals to the root of 7 units, and then we defined this angle as theta, we defined angle BDF is alpha, we defined angle ECD as gamma, and we defined angle DEC as beta. And we know that the sum of the angles in any triangle equals to 180 degrees, and especially the sum of the angles in triangle BFD equals to 180 degrees. That is to say, 60 degrees plus alpha plus theta equals to 180 degrees. And in this way we created our first equation that states that the sum of the angles in triangle FBD equals to 180 degrees. And it is also true that the sum of the angles of triangle DEC also equals to 180 degrees. That is to say, 60 degrees plus beta plus gamma equals to 180 degrees. So the second equation states that the sum of the angles in triangle DEC equals to 180 degrees. Okay, so we have created 2 equations. Then we added equation number 1 to equation number 2, and we got this expression. And then we created, so this is the third equation. We created the fourth equation that states that the sum of the angles of the upper side of any straight line equals to 180 degrees. So the sum of the angles in the upper side of the straight line BC equals to alpha plus 90 degrees plus gamma, and it equals to 180 degrees. That is our fourth equation that states that the sum of the angles in the upper side of any straight line equals any straight line or any line segment equals to 180 degrees. That is to say, alpha plus 90 degrees plus gamma equals to 180 degrees. Okay, so we got from the fourth equation that alpha plus gamma equals to 90 degrees. But we have in the third equation also alpha plus gamma. And if alpha plus gamma equals to 90 degrees, then we can substitute alpha plus gamma by 90 degrees at the third equation. So we substituted alpha plus gamma by 90 degrees in the third equation, and we got that beta equals to 150 degrees minus theta. Okay, we found the value of beta, it equals to 150 degrees minus theta. Okay, we will use it later. Okay, then we actually calculated the value of sinus theta here according to the law of sines. The law of sines states that in any triangle the following relationship exists between the sides to the angles of any triangle. A over sinus alpha equals to B over sinus beta equals to C over sinus gamma. It is true for any triangle. So we can implement the law of sines in triangle BFD. In triangle BFD, FD over sinus 60 degrees equals to BD over sinus theta. Again, in triangle BFD, FD over sinus 60 degrees equals to BD over sinus theta. Okay? FD over sinus 60 degrees equals to dB over sinus theta in triangle PFD. Okay, so we have all the missing variable here except for sinus theta. So we got, after the calculations, that the value of sinus theta equals to the root of 3 over root of 7. Then we derived from sinus theta the value of cosinus theta by using the first trigonometric identity that states that sinus theta squared plus cosinus theta squared equals to 1. We subtracted from this trigonometric identity sinus theta squared, and then we took a root out of this equality, and we got that the value of cosinus theta equals to the root of 1 minus sinus theta squared. We know that sinus theta equals to the root of 3 over 7, so sinus theta squared will be equal to 3 over 7. Okay? Sinus theta squared equals to 3 over 7, and we substituted the value of sinus theta squared in this equality by 3 over 7. 1 minus 3 over 7 equals to 4 over 7, and the root of 4 is 2, so we got that the value of cosinus theta is 2 over 7 units, while the value of sinus theta is the root of 3 over root of 7 units. Okay, but we have already found, as I have already told you, we'll use this equality later. Okay, B, we have already found that from the third equation that beta equals to 150 degrees minus theta. If beta equals to 150 degrees minus theta, then sinus beta equals to sinus 150 degrees minus theta. We have the second, in order to find out the value of sinus 150 degrees minus theta, we have the second trigonometric identity of sinus alpha minus beta. According to the second trigonometric identity, the value of sinus alpha minus beta equals to sinus alpha cosinus beta minus sinus beta cosinus alpha. So we can use this equality in order to find out the value of sinus 150 degrees minus theta when alpha equals to 150 degrees and beta equals to theta. So we use this equality in order to find out the value of sinus 150 degrees minus theta, and actually all equals to sinus beta. Okay, whatever we will find that the value of sinus 150 degrees minus theta b, it is actually equals to sinus beta. So we got actually that sinus beta equals to 5 over root of 7 times 2. Okay, in the next step we implemented the law of sines in triangle DEC, and according to the law of sines in triangle DEC, DE over sinus 60 degrees equals to DC over sinus beta. Okay, in triangle DEC, DE over sinus 60 degrees equals to DC over sinus beta. DE over sinus 60 degrees equals to DC over sinus beta according to the law of sines. Okay, and we actually have all the values of all the variables here, and the only missing variable here is B. The value of DE is B, it is the only missing variable. We put all the data inside this equality and we found out that the value of B equals to 4 times root of 3 times root of 7 over 5 units, and we have already found out that the value of A equals to the root of 7, and actually the area of triangle, the green triangle FDE, equals to the base of the triangle, that is B, times the height to the base, that is A, over 2. Okay, the height creates 90 degrees with the base, so the height is A and the base is B, so it is A times B over 2. Okay, the area of the green triangle equals to A times B over 2. We know that A equals to root of 7 and B equals to this expression, and all divided by 2. So A equals to 2 times 7 over root of 3 over 5, or the area of the green triangle DEF equals to 14 times root of 3 over 5 square units, or in terms of numbers, the area of the green triangle equals to 4.85 square units. Again, the area of the green triangle equals to 4.85 square units. Okay, thank you very much.